I wanted to do this video on Stator, on what you should see, like read out, is it going bad or what's the deal? Well, I'm going to hop right to it. The charging system is completely separate from the spark system, and your Stator is based underneath your flywheel. If you got this far, I noticed this nut that holds it on, and well, there's other videos on how to take that off, and essentially it's a pain in the butt to take this guy off, but you got to have a puller first of all, and then you pry up with a pry bar, and a little bit of heat, and actually a lot of bit of heat, and it theoretically just goes pop right out. So there we go. Camera rolling for you. We'll go ahead. This is already loose once again, and this particular one, there's a little key that goes right there that holds it in place. You can see it grooved out right there, and the Stator sits right there. And if you made it this far, you want to look and make sure all your little magnets, or however it's designed, I'm sure different makes and models might have them pressed in, but yeah, this is it. This is how it works. When it moves, it generates the power. Okay, so I'm going to kind of compare exactly what you're looking at. The wire itself is isolated from the ground. Imagine that the glass is the ground. And inside this bulb, you can't see inside this one, but the filament is not touching the glass. And what I'm trying to say is, again, this wire just wraps a whole bunch of times around this iron. And if you know how to test the light bulb, you can test the Stator. All you do is you put your ohm setting on your meter, and then you'll have like a readout of like 5 to 10 ohms on your incandescent, not your LED. Let's not try to confuse people out there. But you'll put this on, and it should read something similar. Okay, you're going to flip your meter over to the ohm setting, and like the light bulb, imagine the whole ground being like the case of the glass, like I was just talking about. And you shouldn't ring at all, so we're going to make sure that we have a good ground here, and the meter's going to say 0.8 ohms. Yeah, that's direct contact. Okay, so now I'm going to touch this little prong over here. See how I'm doing? Like that. See how it still says out of limits? OL means I can't detect anything. That's all it says. If you are doing that, ringing it out with it, and the flywheel's not off, for example, and you touch that and it's giving you like millions or something like that, or thousands, it's bad. You need to replace it. Alright, and so now I want to talk about this guy. This is the regulator rectifier, okay? So if I was to put this all back together, alright, go put the flywheel back on, kick it on. Let's say I go ahead and get the engine running. And this will put out like roughly 25 to 30 volts of AC, not DC, AC, okay? That's the pulsing. That's how this is set up. It's alternating current. And so it goes into this guy, pump, 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 pump. Some magic happens in here. It squares off the highs and makes it only go one way, and that's converting it to DC. And when it does that, this goes to your battery, alright? That's your little 13, 14 volts putting out and keeping your little battery charged, alright? And this has to be grounded, okay? You can't have this, dangling or anything like that. They don't always look like this. I'll show you another one. This is another mower I pieced together. This one's a John Deere K14, 14 horse. And obviously, you can tell that is not factory. Alright, so again, I have my two AC wires. It's coming off my Stator, and then it goes to my battery. And yeah, I probably should mount it a different way, but this video is just for demonstrational purposes. The other part I wanted to mention is once you check for ground, just make sure it's not broken to the frame, and it's shorting out. That's what it'd be called. Once you do that, you want to check both ends like you would the light bulb. And you can see here it's reading 2.1 ohms, which is great. You don't want anything like over 10. I mean, maybe I wouldn't, you know, because when you get to high impedance, high resistance, it's just simply not going to put out that much. You got to have something like the number you're seeing right there on the meter, and you're good to go. And if you're wondering how much power will this one put out, this one's not going to put out much. Anytime you see more copper wound and smaller copper wound, and thicker gauge and stuff like that, it'll put out a lot more power. This is a basic one. It's a little garden tractor is what you could call this, because that's what it is. It's a John Deere 116. All right, so there's really no electronics on this thing. It's all mechanical, and you know, it could even run with without the charging system. And for a while, I was running it, and that's what I'm trying to say is, remember, the spark is completely separate from the generator circuit. So don't get that mixed up. Yeah, I just ended up moving mine over that way. The factory one went that way. It was a completely different setup. And I'm going to have to mount this modern one up someplace. Technically, it's where the battery's supposed to sit. But I'm going to skip this. I mentioned there's a right way to mount this, which is right side up and wrong side up. If you look at where the bolt goes through, one side's bigger and the other side's smaller. Make sure the side matches correctly when it goes into the unit, otherwise it just won't seat right. Okay, there's 2 bolts right there. Got it mounted right there. So all I got to do is plug that in, ta-da, and then hook that straight up to battery. Oh, mind you, I put a fuse. Alright, and you can see that I got my little fuse holder there. Alright, got my ring terminal for battery side. Okay, I'm using bullet connectors. You don't have to use bullet connectors, but yeah, I had to cut the other bullet connector because it was a different size. So yeah, this is battery supply, so I want it to be enclosed for safety. And yeah, it's going to plug right in there. All right, go ahead and fire this up. Right now we're at 13.5. Cool.